So welcome everyone to this officially last session of Spring I/O 22. How do you like it? Was it good? Good show? I just realized that I've had the pleasure to have one of the first talks and also have one of the last ones. Who of you is here because of the talk on yesterday morning? Who's here because of my tweet yesterday? Nobody. You're the guy you want to see me suffer, right? I decided to not do any slides. I had an idea for the talk. I didn't have any slides until yesterday, so I thought, yeah, just show up this way here. We talked about about modularity in Spring applications yesterday on a conceptual level, and the different levels that you can actually try to apply that. What I'm going to try to do today is to just have a bit of code. I have an example application. It's not an example application. It's basically start.spring.io, not adding any dependencies, not any functional Spring dependencies, something like data repositories or what have you, but exactly that, just a bare bones Spring application. And what now, right? That's kind of the question. How do you actually structure stuff, and how do you arrange code in a way that it is actually maintainable and easily maintainable? So what we're going to do is we're going to create two modules. For the ones in the back, can you actually read the stuff on the right side of the window? Is that okay? It's probably becoming a bit weird for me if it becomes too large here, but is that slightly better? Okay. The stuff on the left is not, that stuff over here is not interesting. It's just, we're going to create a package. We want to build a module, right? So we just randomly name that module A. I deliberately don't try to do anything of like any domain here because it's not the point. It's kind of just like trying to explore what kind of stuff we can do to actually have different modules and how they interact with each other. So we create a class, let's say, call this service. Spring developers love services. So you see it's in module A, and we make this a Spring component, right? That's kind of the way Spring applications are usually structured. You have different Spring beans that interact with each other, and for that interaction, we actually create a separate module, like module B. And we create not surprisingly, a service B, right? And we also make this a Spring component. And we're going to create a dependency here, private final service A. Let's call that service A. Why it doesn't? Oh yeah. Using Lombok here to create a constructor for that. So effectively, we have just created a constructor. To stick with the component notion here, we have described a class called service B that expresses the need for a collaborator, something service A, from a different module, right? So we're using packages to describe modules on the top level. So that's the fundamental, the first step here. We have our Spring Boot base package, or Spring Boot, where the Spring Boot application class lives. Here is the example package, and we use the direct child packages to scope some logic in the first place. Let's see what we can do with that later on. But we can actually, we could run this. I have a test, and I want to just like plug a bit of code in here saying modules off, and then point that to my Spring IO application.class, and then we get back something that is modules, whatever that is for now. And for those, we just go ahead and say for each of the modules we do system out println, right? So what do we have here? Println. That's kind of it. Let's run this. They should do something, and you see there's some output here, right? So what's going on here is, and I'm going to reveal what kind of that stuff is later, but it seems to like align with my kind of convention. We have discovered modules that have an identifier. They have a logical name, which seems to be like the local package name. They have a base package, and we found Spring Beans in there, right? So that's kind of neat. And let's go ahead and introduce. Oh, we have that initial dependency, right? So we have. Oh, we've created that. So let's go ahead and create something that is a separate thing in here, like a separate class. So we now have what we've established so far is basically 2 separate modules and a connection in one direction. That is a Spring Bean that could be. Let's introduce some business logic. Do something. That's not going to be business logic. Don't be afraid. That's a great thing to say to developers, right? That's not going to be business logic. But we will actually call a method do something else on this thing, and then basically use our IDE to just do nothing, right? So we're going to do that. We're going to need that later on. But we could actually we could even like use that thing and call the method. I'm just like preparing stuff for later on in this case. Let's say service A, like this thing here, has some collaborator within the module. So we have something class something other A that is just depended on by service A. Private, again, same thing. Final other A. Other A and this one. The thing I'm doing is called crowd computing, if you're asking, right? So it's like one person coding and like a room full of people watching. So what does that actually kind of abstract here? It's kind of the idea. Let's say you have some user management or something, and you actually have some service API that does an business critical thing, like things like encoding passwords or what have you, right? The other like that logic living inside that component here. So it's accessible, publicly accessible. So we could actually create a reference. Oh no, I wanted, forgive my ignorance, but I wanted to move that into, what do I do? I just moved stuff around. That probably didn't help. So I actually wanted to create that inside service B. I'm sorry. That's what you get if you're not practicing enough. Go ahead. Why is that not compiling? Can't be resolved to a type. What's going on here? Did anyone see why it's just like completely broke everything? The POM? Oh, Jesus. I removed the POM. Why did I do that? The POM? Wow, gosh. So you now just learned the benefits of crowd computing, right? There's like hundreds of developers knowing better than you, and that's always a pleasure. So back to where we started. So we have this other B here, right? And we could, it's public. There's nothing really changing except that I have to rename that to be consistent. But we could actually get to the idea that, so we have service B depending on service A and service A depending on that other B. Does anyone see a problem with that? Hectic nodding, that's great, right? So there's a cycle in there. So what does our test actually do here? It doesn't do anything, right? If you just run it again, it's like, So what we could do here on this modules thing is we could just call something called verify. And that's helpful because that breaks a test. Does that make any sense? Breaking the test, how could that be helpful? Well, you could find out about the cycle. So it still like prints the output here, but it actually throws an exception saying this module A thing depends on module B, and this module B thing in turn depends on module A. Without you doing anything clever, setting up additional tooling or or what have you, right? So it's kind of just the high-level way of avoiding mess, basically, and like not getting in the way in the first place, right? So apparently there's something that establishes the notion of a logical module here, and that does a couple of rules in there. For example, or things that we, as the Spring team, do not actually recommend doing, like field injection or what have you. That would be rejected as well. Right. So how could we prevent that? I mean, we've just run this test here that basically apparently creates that logical module model and then verifies it. But we could actually have done better here, because if other B is just an internal component of the service B, then that's actually, we have to add the, sorry for that, we have to add the valid dependency, right? So that's kind of the internal thing that we wanted to do. This thing here does the business critical encryption of something, and we want to do something like other B dot whatever, right? So that would imagine other B to be a repository or something, right? So we don't want to expose that. So we could actually go ahead and use the means that Java gives us, make that package private, and immediately get the compiler to notice, oh, there's a reference into an internal component that is actually not intended to ever exist. So it would cause us to find out about that problem, and then that basically triggering either the change to, in this case, service B, referring to service B is not really an option, but okay, have the discussion, okay, how do we actually solve this issue here, right? So we kind of have to remove the cycle and find a better way of the modules interacting. The thing I'm trying to get to is that package scope is kind of a, not poor man's, because we're not poor, hopefully, way of separating the stuff that is exposed to other modules from the stuff that is implementation detail and could basically just live in here, right? So what if, I mean, that's very simple. We have just a single base package. We could, or what we're going to do next is, how do we test this stuff here? Module B, right? So let's write a test for that module B, an integration test, I have to say. Module B, we put them in the same package, call it class module B tests, and we can actually use something called @module test, right? Or what we probably would do usually is Spring Boot test, and run this, and it would hopefully work. Does anyone see why it shouldn't? Oh, I need to put a test method in there, don't I? Yeah, and then it should actually be able to run this. That doesn't work. Why doesn't it work? No such bean definition. Other B. Okay, we need to make other B an component, of course. Oh, that works. Okay, so we can bootstrap that thing. And what it does, it basically bootstraps the entire arrangement. But wouldn't it be nice if we were just able to just test module B individually? And actually we can do that by switching to an annotation called module test. And what that does is it kind of traverses the package hierarchy, basically, from module B. It finds the package in which the Spring configuration class resides, considers that the main application package, and then basically applies the same module conventions, so that it would actually try to bootstrap only the components that reside in that package. And that should actually break the test as expected, because there's no bean of type service A available all of a sudden, right? If you have a look at the log output, it basically tells you what it's doing. It says bootstrapping module test for the module B in standalone mode, and it then again basically renders the same output as we've seen before. We do some bit of ASCII art on differentiating between package protected beans and the actual publicly available beans, right? And and the interesting thing that happens here is that we're reconfiguring both the Spring Boot auto configuration and entity scanning and what have you to exactly that module package that you're running the test from, right? You could have them in further nested packages if we would find that particular package in the first place. And it fails because if the component scanning is restricted to that particular package here, then of course service A is not part of the component scan, is not actually found. So what do we do to change that, to actually get the test to work? We go ahead and just use Spring Boot's mock bean convention called service A, right? So that's the thing here. Should be able to run this now. It's green again. So we have a pretty clear description of, okay, this is a test for that module. And by the way, that module refers to some other components in other modules. And we describe that here. And it's now, it would be our task to actually describe how we expect that service to behave. And then we could just set up tests here. Another or a different way of actually approaching this, we're testing this module. It said, if you remember, the console output actually said in standalone mode, right? So by default, we would just try to run that particular module. There's a couple of options to be put here. It's the bootstrap mode. We could have all dependencies. For example, we could just remove that again and then run the same thing. And it would now, if you look at the log output again, we would see that we're running in a different mode. So that's the module that we actually want to run. And because we can analyze the dependencies, the module dependencies into that other module, and we basically include the other module in the bootstrap as well. So from the entire web or graph of module dependencies, we would basically select the subgraph that's needed to actually run the tests for that particular root module and run all those, right? So you're getting some kind of flexibility what you want to pull in there. There's also the ability to, I think extra includes, you could define, if you want to be very specific about it, you could go ahead and define, I want to do example, what have you, right? So the module identifier has to be put here, basically. Let's go back to using the mock bean. So how would you now verify the interaction in the first place? We would get the access to to service B, right? So we're using again constructor injection service B from our tests. We make the required args constructor, so we actually get that injected, and then we call service B, right? So we invoke some business logic on that very bean, and then we go ahead and say verify service A dot do something else, right? That's supposed to have happened. If we comment that out, we should see the test fail. It does. That's kind of neat. So we expected that interaction to happen to the other module, but it didn't. And if we uncomment that again, then it should actually be green, right? So we have the arrangement now is that we to bootstrap the module B, we actually need to provide that instance of the other service. This way I wanted to go here, right? So that we can actually, that code can actually work, and yeah, so and we can actually verify that interaction through the mock, right? So we verify that the module B actively reaches out to use the other bean. That's kind of neat, but it actually is not really, or doesn't have the modules decoupled really, right? So a different approach actually is that instead of calling the service, we would we want to publish an application event. So let's say this is, yeah, I've like said we wouldn't want to go into a domain, but let's say this is kind of like an order management service. We would like complete an order, and for that to happen, some inventory has to be updated. So we create a new class called order completed, right? That could be the. I didn't think this through to the end, I guess. And instead of using the service, we change this, and rather private final application event publisher, and in here we go events dot publish event new order completed, right? So that's kind of the way you work with application events in Spring. You either directly use the application event publisher. There is some in Spring Data integrated way of doing that in a slightly more elegant way, so that you can actually avoid the dependency to that Spring component. But in the end, it's just that service be publishing an event, right? So we actually get rid of the dependency to service A. So we're not actively reaching out to the inventory anymore, telling it to update the stock. But how do we actually, so we can actually get rid of this in the first place, but how do we actually verify the interaction then? Well, we can't anymore because we're not actively interacting with the other service, but we can now verify that we have that particular event was published, right? And we do that by saying published events. That's that argument being able available for injection is a consequence of using that particular annotation here, and then we can then say assert that events dot. Oh, I think I need to do this one here. Of type order completed class. Is that? Yeah, it should be. We just expect that it has just one event published, right? And that should actually do the trick, right? So we should be able to run the test. It's red because we haven't compiled this thing here. Yep, that should do it, right? So you see, that's green. So we've kind of moved back, or we pedaled back a bit from actually formulating some expectations about what other things are invoked in the other module, to solely that module focusing on doing its own business logic and kind of notifying the environment about the stuff that happened using these events. And we could actually go ahead and on the other side here have an event listener void on what is it, order completed. I don't think I made it public, did I? Nope. And again, these events now implicitly become part of the public API, right? So we do on order completed here, event, and then we do what have you, whatever you would put in here, right? And you can actually write a test case easily on the other side, on the service A side, to inject, get the service A injected, and then like just create a new instance of that event, and then put that into the service and verify on the outcomes of what's supposed to happen here. So instead of like verifying on the interaction between the two, we test both of them in isolation and have one test for the publication of the event and one test for the other. So that that has been a quite an interesting like thing in the first place. So we were able to create these kind of modules and put parts in there, hide some parts. We can use or switch to event-based interaction between the individual modules. But assuming this is growing quite a bit, right? Then there's the question: okay, what's in the event even? Or what's not in the event but in the module, right? So for someone new joining the team, like you have to tell them, okay, what modules are there, what kind of API is there, what events do they consume, what events do they publish, and you can of course let them go ahead and just look at the code here. But all this information can actually be extracted, that we put in here, can actually be extracted into, that's already available in this model here, and it can be written into some ASCII doctor-based documentation. Let me just grab this here. Well, yeah. I always forget like the canvas options and what's available here. There's some Jesus, come on. Options, canvas options. We prepare some setup. We're literally using the defaults here, and then use the modules instance and the documenter available to actually tell it to write out some documentation, right? And we run the test here. I guess that for each we can comment that out for now. But that line down here actually creates, and I have to probably zoom in here now, that Modulus docs folder here. And that renders a couple of things. It renders a UML file for, where is the window, show view, other plant UML. It actually renders like just a simple diagram that represents our module structure. It's not terribly complex here, but it actually gets quite complex if you add a couple of more modules. It actually differentiates between different kinds of relationships between the modules, like whether they're listening to events in the other module or whether they're actively using just types, right? There's even a third kind of dependency that we describe as depends on, which means that there's an actual bean reference, right? So if we module A to module B, we could, did we have B referring to A? Yeah. That's kind of, I mean, we just get UML diagrams rendered for both the entire arrangement and the individual modules as a starting point, because the diagrams can grow pretty quickly in basically complexity. The other thing, and that's pretty interesting, I think, is that we render a so-called module canvas, which means that we can actually look into each module and document a couple of different things, right? We can find all the Spring components that are available in that very module. There's published events. There's none in here. There should be even none in there for module B. Like, as I said, the modules, the events are part of the API, but for some reason, published events is not showing up here. Right? So why is that? We're inspecting of course, the individual packages for types for Spring Beans and what have you, and it turns out that we haven't actually described this thing as an event yet. And there's a project called JMolecules that I'm already using here that gives us either annotations or marker interfaces that we can implement with our types, so that if I run the test again, we would be able to just discover that this thing is a domain event, and by the virtue of that, we should see that over here we actually now find both the event and the point in the code that actually creates these events, right? So we can actually see that, okay, this module exposes these events and they are created at those points in the code base. It also says, or that table here also says properties. We're kind of describing the module as a component here, right? So we're describing the provided API, which is basically the public types that are in there, and the events that are published. But Spring configuration properties are usually kind of both. They provide, or they allow you to tweak certain things about the module's behavior usually. And at the same time, if you have required properties, then they actually tell you they're part of the required interface. So stuff that you have to configure to actually get stuff to run. So to show you how that works is you would just create what is it? Config properties B. In this case, you would just create a class. It's a standard Spring Spring Boot feature of, let's make it a value because that's pretty simple. Just some property, and let's add some Javadoc here because we want to document these things. And there is there's an additional dependency that you can put into the project for which that scans basically your configuration properties classes and actually creates metadata, extracts the metadata from that. And we're using that to, I think I need the add constructor binding. We still have to investigate why we still need that. Actually, with Spring Boot 2.7, that annotation should not be needed. But we run the tests again, not the module tests, but the tests using the documenter. If I run those again, then that should actually pick up the properties and kindly document both the existence of the property as well as it has extracted. If you see that over here, it has extracted the Javadoc from that, right? So it's kind of like you just do quote unquote what you've been used to with Boot. You kind of declare Spring components, you publish events, you declare configuration properties, and we would kind of separate, or the value add that you get with that is that you kind of have, you of course have other things in there like JPA entities and aggregates and repositories and whatnot, and we kind of find the important bits and just don't bother to document the less important bits, and you can include that in your ASCII doctor documentation that you want to use with the rest of the project in the first place, and you get that for each module, and it's kind of a neat overview about the stuff that you've basically documentation, developer documentation. There's one additional trick. If you actually expose Javadoc for the projects, if you deploy that to some place, you can. That's the soundtrack to coding. That's fine. All good. No worries. There is a with API base, and we say basically just handed the URL of the HTTPS yada yada foobar something. If we register for the rendering, we register this is where we're going to eventually publish the Javadoc. Then you actually get a slightly different output because all the public types that will show up in the Javadoc will actually even get linked. So you can seamlessly connect your high-level developer documentation with your Javadoc so that whenever you just like click on those links, you jump to the next level of detail, basically. All right, so what is this thing that you see here? It's kind of the result of some R&D work we've been doing for quite a while now. And I think I presented on a prototype of this 3 years ago at the last Spring I/O. It's called Modulus. We've just recently decided to make it an official Spring experimental project, so it's going to probably move into the Spring experimental bug tracker going forward. And it's exactly that, right? It's a kind of low effort module, not system, but idea of how to actually implement modules in Spring applications. It's not it's working on the class path. So you're totally free to actually split up your application into different artifacts or different build modules. It's not depending on that. You've seen the testing integration. You've seen the documentation integration. There's like 2 more things that I would like to show you. Or so far we have only used Modulus in the testing space, right? So it's been a test level dependency, so it doesn't actually alter the way you run your boot application at all, because at runtime, if you just run the boot application, it would still bootstrap all the modules, all the things. All we have done right now is basically verify the structure during a test case, and we've generated documentation using a test case. Plus, we have the ability to actually run individual modules, parts of your application in your tests. There are a few runtime additions or runtime features as well. One of them is the observability feature here. That's probably worth exploring a bit. If you build the same kind of system as a distributed one, right, consisting of individual microservices with Spring Cloud Sleuth and the micrometer integration, you actually can trace a call to the system, how it actually propagates through the individual systems, right? What we've built here is that we can actually do the same for the logical modules, right? So if you add the actual integration, it's just yet another jar, basically, for your Spring Boot application. We would kind of find all the Spring components that make up the API of your modules, and we would instrument them the same way that in a microservices arrangement, the individual HTTP calls would be arranged, it would be instrumented, and we can then, for a call from the outside, we can actually create the traces that you would see in a distributed arrangement in the same way in this case monolithic arrangement, right? So that would kind of assume you have a system that consists of 3 or 4 individual services, each of them consisting of 3 or 4 individual modules. You would basically get all the details, like the spans that cover the network requests, but also the invocation flow through your monolithic modules, basically, right? That's kind of just a sample one from another sample project I have, and that information then basically rendered, or it's Zipkin, I think, if I remember correctly. Yeah, right. All right, that's that stuff, right? So it's runtime observability support. There is also support for, I'm not sure I want to get into that too deeply. If you're using events for service integration, right? Let's say we've done this here, right? We've published the order completed event. Let's say we wanted to send out emails or something for in case of the order completion. We cannot actually implement that through a synchronous event listener. This one here would be invoked synchronously, right? So the standard event listener mechanism in Spring. Because in the best case, we send out an email, or there's a couple of problems that could come up here. First, we're interacting with additional infrastructure, so the SMTP server could just like be slow, right? And that would kind of span our transaction boundary here. So assume this thing was at transactional, right? Then what was that? Oh yeah, I don't have the transaction annotations even in the class bus here. But assume this is transactional, then we create a transaction for this, and if the event publication actually causes some long running process involved, or in this case just the sending out that email, that could just like span blow up the transaction unnecessarily. Another problem could be that if we were sending out that email and ultimately persisting the order state change fails, then we have sent out an email without the order being completed, right? So there's a reason why you would rather actually consume that event asynchronously and on transaction commit. There's like Spring native, not Spring native, but just standard Spring means to achieve that. It's, I think, at async at transactional event listener. That, however, means that the original transaction that completed the order, has already completed, And if then, for example, sending out that email fails, then that event is kind of lost, right? With Modulus, you get some kind of tiny extension for the, and I actually have the, let me try to find that thing. There's even an example for that. In some other project, I make sure that you actually get access to that. If you email notification tests, there's an extension in Modulus to the Spring application event publication mechanism that kind of finds out about all the transactional event listeners that would have to be invoked during a transaction, right? In our case, as I described, the email sending event listener. And it actually stores that information that this thing has to be invoked in some kind of event publication log and removes those entries again as soon as that listener has successfully completed. And if it doesn't complete, that entry stays in the log and could be retried and what have you. So you get some kind of like more reliable event publication into transactional event listeners. I'm just running this one here real quick. It should actually become green, but it should list that there are so-called outstanding in terms of not done yet, not in particularly great. It's here. So what it basically does is it sends out, there are two event listeners here, one completing successfully and one is not completing successfully. And the one you see if you skim through this and actually check the SQL statements here, one of the event listeners basically gets that log entry removed, and the other one is just being kept around because that other one was failing. And then the registry, in this case here as a test case, concludes. It just outputs that here's the publication, the unfinished publication, that if I wasn't using an in-memory database here, because all I want to show you is that log output, but if it's a real database, then that entry would just like survive that failure. And there are certain strategies how to actually republish the events that we originally published to the event listeners that failed, right? So you can basically get that kind of reliability here. So reliable domain event publication, that's kind of the thing that you get with that, which you kind of need if you want to integrate your logical modules using domain events, and that's what Modulus basically ships with. The final thing, and I guess I'd be open for questions, is the challenge of dealing with time-based invocations of business logic, like creating a PDF report at the end of the month. And it's usually been a bit of a challenge to, like, not a technical challenge to build because we have scheduling in Spring, but it's kind of like tricky to test, right? Because how do you like even do that? There's been a blog post by Passage of Time Events Implementation. Let me just try to find that blog post by Matthias Veras. He's kind of suggesting an alternative approach to not really scheduling, but time-based events. So he's, in the first place, considering the passage of time to be events, right? The day has passed, an hour has passed, to model these incidents as actual events, and so that you can actually write code against those, right? You can basically declare an event listener to the day has passed event, and then do stuff with that, reacting to it. And that easing the way that you can actually build tests, because by just writing a test that basically says this day has passed, this day has passed, this day has passed, you can kind of easily test that that functionality without without actually having to deal with time here. There is an implementation of that coming with Modulus. Let me go back to the service B example and put an event listener here on day has passed event. We do something. What can we do reasonably? We could log something, right? SL F4J log dot info foo, and let's take something from the plus event dot get date. That should be it, and that's got to be an event listener. And the thing that we have to do is, or I think I've already done that. This is the moments module of the Modulus thing. I can enable a time machine here, which gives you an additional Spring Bean, basically, that allows you to travel in time. Isn't that fancy? You can actually go ahead and just inject here private. Nope, not private method. Private final time machine. Oh, Jesus. Time machine. Alright, so what do we do with the time machine? I mean, let's do another test here. And just say time machine shift by duration of days. Let's fast forward 10 days. Where are you going to be in 10 days? Okay, folks, does anyone know? I don't. At home, I hope. So if I run this, you see that there is like log output generated. So it's not like that we're really shifting time, of course, right? But we're just like publishing events for like each of the days, each of like fitting the delta here. There's an hourly event that can be thrown. I think there's no smaller kind of interval than hours, basically, but you kind of get the gist of it, right? So it's kind of easy to just go ahead and say, okay, run or shift the day by the time by a month or so, and then be able to verify PDF report generation or something like that. So a pretty easy and straightforward way to not have to do with scheduling and all this kind of stuff. Under the covers, of course, if you run the application, then of course scheduling is enabled, and like every hour and every day we just publish these kinds of events for you. Right? So it's becoming kind of the toolbox for stuff or challenges that arise when you try to build modules in a standard Spring application, like logical modules, not talking about Java modules in this case, of course. Oh, and yeah, there's tons of other stuff to explore here. I'm running a bit out of time. Of course, you're not like in the luxury of always just having a single package here. You could have like nested packages. By default, they are just considered internal packages, so that verification that you've seen in the first place would have rejected any kind of Spring dependencies into any of the nested packages that you put here. Tons of configuration options, more to come. Watch the space. It's modulus.org. That just routes through to the GitHub page right now. Current release is 1.3, so we're kind of considering this like 666 stars. Oh. Interesting. I didn't plan for that, just like I didn't do for the demo. All right, that's kind of it. So I hope you feel you've got a bit of a toolbox for your module endeavors with your Spring applications, how to structure them, and what have you. And if you do similar kind of stuff, have input for this, don't hesitate to get in touch. There is a Twitter account here, or the classical Drotbohm at VMware. Although I've heard this might change in a couple of months. Feel free to get in touch. I hope you enjoyed this. And yeah, enjoy the weekend in Barcelona, the rest of the conference. Thank you.